very much for the introduction, and very good afternoon, everyone. I hope you are fresh off the break. Okay, and today I'm going to talk about the Qsar modeling, and especially we are using a data mining tool. As we know, the Qsar is one of the virtual drug screening approach, and it has a number of advantages. And as it is a data-driven approach, the natural question is, and what kind of data mining tool we can use, and particularly, and how do we characterize the substance and using molecule descriptors, and how do we use it for the say the overview of our data or the prediction or the optimization. And today I'm going to show you two examples and using one of the data mining tool. And before I give you the example, let me first introduce what kind of data mining tool we are using. And we are using Simica, and Simica is a tool for multivariate data analysis. It has a number of applications, including the Qsar, ADME, and also omics area, including metabolomics, genomics, etc. And also Simica can be used in the other application areas such as analytical technology, spectroscopy, and chromatography, and also the process development. Okay, and I'm from here, Singapore, and we have an office around the world over here. Okay, now let me show you the two examples. The first one I'm going to show you, and we call it CAM GPS. Actually, it is drug space, and we collect a number of data, and we use the descriptors to characterize the data, and then we want to identify and investigate the properties such as lithophilicity and polarizability, charge, flexibility, etc. And in this drug space, we have 552 compounds there, and we are using 72 chemical descriptors. So now we are going to do a multivariate analysis of this data. Say, for example, this data, we have that kind of observation and that kind of variables. And how do we identify and do investigation of this data? And particularly if we have a new molecules, and if this molecule can be functioning as a drug or not. Okay, so first of all, we are doing the principal component analysis. And here is the result of PCA. We call it PCA over here. And see, we have 72 descriptors, the variables. And by using PCA, we can project many variables into low-dimensional variable. In this case, we have two. And this one, we call it the first component as x-axis, and horizontal axis, the vertical axis, the second component over here. And also we can have the smiles notation here, and anyone, because here, and each dose representing a molecule. And if we select anyone, and we can see their smiles notations here. And also we can do cluster analysis, and we can classify into different clusters over here, and we can see these dendrograms over here. So here's the data analysis, and further we can understand the important properties of all these molecules over here. For example, and here is the score plot, and this one is exactly the same as this one. And if we are particularly interested in some properties, for example, the molecule weights, and we can color it. And from this visualization, we can see, and this direction is something like molecule weights over here. And we can see from the left to the right the molecule weight will be increased over here. And similarly, if we are particularly interested in this property, and we can color it correspondingly, and we can see this direction, which is the second principal components, we call the PC2, and this is related to hydrophilosophy of these compounds over here. Okay, if we are interested in the others, we can also color it correspondingly and to see the trend. So here we can see the overview of our molecules. And also we can select some representative and diverse molecules. And the purpose is we can build our model using a small number of data over here. So for example, here we can select the molecules like this. They are distributed over this space, and they are also representative. And we can use some kind of design method. In this case, we can use statistical molecular design, or we call it multivariate design, to build our model over here. So the next step, we can do we can identify the new compound regarding to its properties over here. Okay, so for example, if we have new molecules here, and we project into this drug space, and we can find its location here. If we want to know their properties, and correspondingly see, for example, in this case, molecule weights, so its molecule weights is something like this. And for the other properties, and we can see this plots or figure, and we can see these hydrophilosophy properties over here. Okay, so the summary of this example 1. So the GPS, Chem GPS in Simica provides a virtual drug screening tool to understand the important properties. We can identify the new compounds and select representative and diverse subset, and we can avoid extrapolation. Okay, and it can also be easily expanded, the drug space. If we have more molecules, and we can put it in and build this model and to improve this drug space over here. So here is the example number 1. The next example, and we can investigate the drug when we do the screening, and we can focus on the other properties. For example, the metabolic degradation of the drug here, over here. So here's the example. So for doing this, and we collect the data and all the drug descriptors over here, and particularly biological descriptions over here. Say if we are interested in this inhibition IC50 over here, and we can build a model and using regression methodology, PLS or OPLS, and we can build our model over here. Okay, so here's the result when we build the models. Since here we separate the data into 2 parts. One is the training, one is the testing. And here is the training results. And from here we can see the prediction is pretty acceptable, I should say. And we can do the validation. And we can have the different set of data, and we can do the justification to say if our model is good or not. Okay, so with this model in hand, and we can do the prediction. Say, for example, if we want to increase the inhibitory potency of the drug over here, and we know and which properties are closely correlated, negatively correlated or positively correlated with this property. And this is very important especially in the early stage of drug screening over here. So from here, in order to increase this, probably we want to decrease this, because they are negatively correlated. So here is just the example over here. Okay, so the summary of this example number 2, Qsar model built by Simica is used for prediction. It can be used, the value it brings us It can be used to flag problematic compounds as a filtering tool over here. And it can also be used to guide synthesis efforts during lead optimization. It can be used to generate compounds libraries over here. So here is the summary of second example. The overall summary is Simica is a powerful data mining tool. It can be used to many application areas, including the QSAR over here. Okay, so if you are interested in how it goes, you can visit our website over here, and all the informations are listed in the website over here, including the upcoming training and webinars there. So with that, I will thank you very much for your attention. I'm happy to answer your questions. Thank you.